Welcome to a brief lecture video for CHEM1004 and 1601 on examination technique. The point of this is not to give you the answers to any of the questions, it is instead to show you different aspects of examination technique and to give you ideas of things that you may want to pay attention to in the coming exams. We take the 1004 and 1601 exams as being important markers of how a student is fitting into university. What we see in this first example are the marks the student got for the different questions that they answered. And we can see that the student did well for the first questions, which were physical chemistry, but less well for inorganic chemistry and quite poorly for organic chemistry. This type of distribution function makes us think that the student either didn't manage his revision well and spent too long focusing on physical chemistry at the expense of inorganic and organic chemistry, or didn't manage his time well during the exam, spending a lot of time and effort on physical chemistry, the first two questions, and then running out of time for the later questions, those associated with inorganic and organic chemistry. It's important when you're dealing with exams to start on your best question and to get the marks for those in the bag before you move on to the other questions. Don't feel that you need to do them in numerical order, do them instead according to your preference and your ability. Before I move on to techniques related to answering the questions, I wanted to emphasize the importance of filling out the form at the front of the answer booklet correctly. You need to write your seat number, the candidate number that was sent to you by registry, not your student number, the title and the code for the module that's being examined, the 7-letter code for the location, the model and make of the calculator that you're using, and finally at the end of the exam, write the number of examination booklets that you've used. This is particularly important as it enables us to make sure that all of your answers are there for marking. Now moving on to some of the examination scripts. In this example we see that the student hasn't written the question number at the top of the page that they're completing. It's very important that you do this because you can answer the questions in any order and you can also go back to a question. Writing the question number at the top of the page makes it easier for us to find the different parts of the question when we're going through and doing the marking. This example was just of an examiner's comment and I thought I would flag it up. Question 6 required you to answer Part A and either Part B or Part C. Make sure that you read the rubric and you understand what it's asking you to do. This example shows a student who's done a very good job of making his answer clear. Crossing out is neat, but again he's forgotten to write the question number at the top of the page and so risks us missing parts of his answer. In this example, the crossing out is starting to get less neat. Also, the student has decided to answer two questions on the same page. Please don't do this because again it makes it easy for us to miss part of an answer. You can answer different parts of a question on the same page, but please make sure that you answer different questions on different pages. In this example again, the question number wasn't written at the top of the page, but I also wanted to emphasize the importance of notation. This question is asking about term symbols, and term symbols are written using capital letters, not lowercase letters. Make sure that you're using the appropriate notation and symbols. In this example we see that the student had forgotten to write the units. Remember to write the units down when relevant. This example shows how easy it is to throw marks away by not giving all that the question is asking for. The question was asking for selection rules, and we see that they've been given for the orbital quantum number L, the overall quantum number J, but they've not been given for the spin quantum number S. And in fact this turned out to be quite a common problem with this question. Another aspect that we find particularly important in physical chemistry, but it's important generally, is to make sure that the diagrams are clear. To make sure that your diagram is large enough for us to actually see what's going on. This picture should have been at least twice the size. Here we're seeing that things are just starting to become messy, and that this is making it quite hard for us to see what's going on. The student even continues to write off the bottom of the page. Instead, please take particular efforts to lay things out clearly and to cross out neatly. In this example again the picture is starting to get a bit messy. It would be better if the student had been using a ruler to draw the lines. Also in this question we see that the examiner has made a comment indicating that the student hasn't given enough in the answer to warrant all of the marks. We recommend that you look at the marks that are associated with the parts of the question and ask yourself whether you think you're giving enough to warrant them. As an indicator, if 6 marks are being given for part of an answer, we may be looking for 6 points. In this example we're seeing very good examination script. Tables are being used to lay out the answer. The script is being very clear, but again the student simply didn't answer all the parts of the question and didn't put the selection rules down. Here we have some more inappropriate graphs. They're essentially the size of a postage stamp. They needed to be much larger, and also there are no axis labels, so it's not clear what is being plotted. This type of graph is going to score pretty badly in the marking. Here we have some nicer graphs. It's a good size. The axes have been drawn with rulers. The characteristic features have been indicated, but again the student has forgotten to put down the axis labels. In the next example, things are just starting to get a bit crowded and a bit untidy, and this has made it very hard for us to see what's going on. Please try to lay out your figures neatly and clearly. Here we're now moving on to organic chemistry, and there's a problem that was common in the previous examples, and that's the student simply hasn't given enough to warrant the marks. As well as calculating the chirality, an explanation was asked for how that was done, and we can't give you the marks for this if it wasn't given. In the organic questions, please be careful to give all relevant mechanistic details when they've been asked for. Here we're seeing that the initial reaction mechanism was not explained, and the student only explained what was happening in the second step. Moving now to inorganic chemistry, here the student has given us some sketches of the 3s, p and d orbitals. This unfortunately earned the students no marks, as the question was actually asking for the radial distribution functions. These are drawn here, but again these diagrams show many of the problems that we've seen before. They're too small. Use a ruler to draw your axes, label your axes, and also any characteristic features. Moving now away from examples of poor examination technique and things we prefer not to see when we mark the scripts, to examples of good examination technique and things that we would prefer to see. Here we see that the equations are nicely laid out. There's plenty of space. It's not crowded. We can see clearly what is going on in the different parts of the answer. The figures are good size. The figure is well labelled. Yes, we would have preferred the student to have used a ruler, but overall this is a very nice answer. This is another example of good exam technique. Things are being nicely laid out and we can see what's going on. And this is really what examination technique is about, making your answer as clear as it can be. Here we've got a nice example of a figure that shows a molecular orbital diagram. Everything is nice and clear, nicely spaced out. The student has changed his mind on the position of the two sigma orbitals, but it's been neatly crossed out. So again, everything remains clear. The bottom line is that we don't want to see scripts that look like this. This is a mess of crossing out. We have small parts of information here in the little box and here at the bottom of the page that the student would like us to find. But we could very easily have ignored this bottom picture because we thought it was being crossed out. The best thing that you can do in this situation is simply put a line through a page indicating to us that you don't want us to mark it, and to write the things that you do want us to mark on a new page. I'd like to end with some general comments. Most of the aspects of examination technique that I've been through are about making your answer clear. This helps us find the information within your answers that are required for the different parts of the question. Make sure that your pictures are appropriate, well sized, use rulers to draw your axes, label your axes and any characteristic features. Make sure that there is enough in your answer to warrant the marks that are available. Make sure that you read the rubric carefully. And finally, it's a good idea just to spend a few minutes at the start of the exam just going through the paper and finding the questions that you think are your best, and to start with those.